We are beginning our chapter on inverse and radical functions. Today we're talking about operations on functions. So we can add, subtract, multiply, and divide functions. With our dividing, the thing to remember is that we cannot divide by 0. So you want to restrict your domain. Any value that would make your denominator 0 is not a part of your domain. For example 1, it says find f plus g of x. That means take f of x function and add your g of x function. So when we're adding polynomials, we're simply going to combine like terms. So negative x squared plus 2x squared combines to give us positive 1x squared. There's no other x term, so to bring down the 3x, and then 1 plus negative 5 is negative 4. To subtract, we want to distribute the subtraction sign, so then everything after the subtraction sign in parentheses becomes opposite sign, and then we'll follow our rules of addition. So negative x squared plus negative 2x squared would be negative 3x squared. Bring down our 3x, 1 plus 5 gives us 6. So you want to make sure you distribute the negative. To multiply functions, by taking f times g of x. F of x is a trinomial, g of x is a binomial. So I'm going to distribute the negative x to the trinomial, which gives us negative 4x cubed plus 2x squared minus 3x. Then I'm going to distribute the 5 times 4x squared would give us 20x squared, and then times negative 2x gives us negative 10x, and then 5 times 3 gives us 15. Lastly, we will combine like terms. We have a 2x squared plus 20x squared that we combine, and negative 3x minus 10x that we also combine. To divide the polynomials, f divided by g of x, that's equal to f of x divided by g of x. So we get 4x squared minus 2x plus 3 all over negative x plus 5. Now remember, we cannot divide by 0. So if you were to put in 5 for x, negative 5 plus 5 would be 0. So x cannot equal 5. A composition of a function is when the output from one function becomes the input into another function. So for example, for part A, it says find f of g of x, and then also find g of f of x, and they're not the same thing. So its composition is not commutative, and it's not the same thing as multiplying. So you want to take note of this notation here. That open circle means composition. It does not mean multiply. So that means the input will be the g of x function into f. All right, so what I like to do is start with my f function, which is 2x minus 5. I know I'm going to be replacing x with something, so first I replace x with parentheses, and then inside the parentheses I put my g of x function, which is 3x. And then simplifying that, 2 times 3x is 6x minus 5. And then the other way around, g of f of x, so I'm going to go to my g function, and in place of x, I'm going to put parentheses. So it was equaling 3x, and then in place of x, I put 2x minus 5. So I put the f function. Then we're going to distribute the 3, so we get 6x minus 15. For part B, the domain, both of them were linear functions. So if you think about lines, they continue on in both directions forever. So your domain is going to be all real numbers, and your range is also going to be all real numbers. Another type of composition of functions, so this time it's h of f of 10. So you want to start with evaluating f of 10 first. You start on the inside, kind of like order of operations, you do the innermost first. So let's find f of 10. So I'm going to go to the f function, defined above here, and replace x with 10. So y equals 4 times 10, which is 40. Now the output of 40 becomes the input into h. So now we'll find h of 40. So I'm going to go to my h function defined above here, replacing x with 40. So we want to make sure we do exponents first. 40 squared is 1600. Then multiplying, 2 times 1600 is 3200, and then our adding. So then lastly, h of f of 10 equals 3203. Next, we're going to find g of h of negative 3. So start on the inside h of negative 3. So go to the h function and replace x with negative 3. Follow your order of operations. Exponents happen first. Negative 3 squared is positive 9. Then we multiply. 2 times 9 is 18, and then we add. So our output was 21. That output becomes the input for g. So next we're going to find g of 21. So I replace x with 21, and g of 21 equals 27. So back to our original notation, g of h of negative 3 is 27. All right, example 5. A movie theater charges $8.50 for each of the X tickets sold. The manager wants to determine how much of the movie theater gets to keep of the ticket sales if they have to give the studio 75% of the money earned on ticket sales, T of X. If the amount they keep of each ticket sale is K of X, which composition represents the total amount of money the theater gets to keep? So we'll start with the ticket price per X ticket is 8.5, so T of X equals 8.5X. Now, if they have to give away 75, the amount they keep is 75%. Or, sorry, they have to give away 75, so they keep 25%. So they're keeping 25% of their sales. So the composition would be that they're keeping 25% of 8.5 per ticket. So when we multiply 0.25 times 8.5, we get 2.125x. So that's just telling us how much they get to keep per ticket. They're actually only keeping $2.12.5. Thank you for watching.